reporting. Linear equations. Linear equations are equations that if you were to graph them, this is the graph we'll be using for this class, right? The x-axis and the y-axis. So a linear equation, when you graph it, it shows up as a line. Our next class is quadratic equations. Those do not show up as straight lines. Those would be curved lines, okay? So in one variable just means that you only have x, okay? So the largest exponent is an understood one, so it's never, sorry, it's not going to be x squared or x to the third. The largest exponent is 1. So not either of those two. So to solve linear equations, list restrictions on the domain of the variable. This is very confusing, but if you just memorize the 2 domains it cannot be, it will help you. Okay, so anytime they're asking about what is the domain, they're trying to get us to, one second, there's a cord bothering me. They're trying to get us to ensure that you never have 0 as your denominator and you never have a negative under the square root, okay? So these are restrictions on the domain. Don't make it pink, make it another color. Ooh, green like that. Okay, restrictions on the domain is anything that prevents, so prevent these 2 things from happening, okay? So if you have 5 minus x, for example, okay, as your linear equation, 5 minus x, I don't want this to happen. So the restriction on the domain is that x cannot be 5, right? X can be -5, and then we'd get a 10. X can be 4, x can be 3, x can be 0. But if x is 5, 5 minus 5 is 0. And that's what we're trying to prevent, okay? If it was something like this, then we would have to say x is greater than or equal to 0. Okay, those are restrictions on the domain. Again, we'll keep practicing with it, but that's what you should think of. These are the 2 situations you should think of when they're talking about what the domain is, okay? So list restrictions on the domain of the variable, clear parentheses by using the distributive property, isolate the variable to one side using inverse operations and collecting like terms. So again, if I had x plus 5 equals 10x minus 4, right? What I want to do is I want to move the variables to one side and I want to move the constants to the other side, and the line is the equal sign. Okay, if you already know this, or this is not, this makes sense to you just naturally, you do not need to write down everything I'm writing down, okay? All right, so we're using inverse operations. That means if you see addition, the inverse is subtraction. If you see the square root, the inverse is going to be the squared symbol. If you see division, the inverse is going to be multiplication, right? And you need to go in opposite order of PEMDAS. So PEMDAS says we do addition and subtraction last. When you're solving for x, we're going to do addition and subtraction first, right? So first we move over the 5, and then we divide by 10. Check by substituting it into the original equation and verify that it is true. Just so we don't run out of time today, I might not do that very often, okay? All right. So let's just remember we're doing a reverse PEMDAS. Our first example was 4x minus 5 is 7. Good. So parentheses, exponents, multiplication, division, addition, subtraction. Addition and subtraction are on the bottom, so that's what we want to do first. 5 is being subtracted from 4x. So to do the opposite of that, I add 5. Anything I do to that side, I have to do to the other side to maintain equality, right? So now I have 4x equals 7 plus 5. I put the 5 under the 7 because they are like terms. So that's 12, right? Stop me when I get something wrong mathematically. Now I only have something being multiplied. The opposite of multiplying is dividing. So 4x would be divided by 4. 12 divided by 4 is 3. Good. So here our answer is x is 3. 3 times 4 is 12. 12 minus 5 is 7. That does work, but always check it, right? The next one, I'm going to run out of space. I know I am. Negative 2x plus 5 is 0. Okay. Now, remember to maintain equality, if I subtract 5 from this side, I have to subtract 5 from that side. Those cancel. I have a negative 2x equals negative 5. Good. That was our addition. Now I need to undo multiplication by negative 2. The opposite of multiplication is division. So negative 2 divided by negative 2. That just gives me x is, honestly, I would probably leave this as a fraction, 5/2. Does that make sense? Why it's a positive 5/2? Yeah. Negative divided by negative becomes a positive. Number 3 is 1/2 x minus the square root of 3 equals 0. Okay, and remember we're worried about getting a negative under the radical. You're only looking at the radical in terms of domain if your variable is under the radical. It's fine because there's no variable, just the number 3, and that won't change. Good. What I'm going to do, instead of finding out what that is, I know it's being subtracted from x, so all I'm going to do is add it. And luckily, I'm just adding it to 0. That's convenient. So now I have 1/2 x equals the square root of 3. Because 0 plus the square root of 3 is the square root of 3. Now, just a quick note about fractions. 1/2 x is the same as putting the x on top. So x over 2 is the same as 1/2 x. Okay. Another example might be 3/2 x. Still the same. I keep freezing every now and then. No. All right. What can I do? Okay. Not much. Sorry. So 3/2 x is the same as putting the x up on top. So 3x over 2. So anytime the x is being multiplied by a fraction, that x is understood to be with the numerator of the fraction. Good. Okay. So 1/2 x is the same as x over 2, which is to say that the x is being divided by 2, right? So if it's being divided by 2, we're going to multiply it by 2. X is 2 times the square root of 3, because the 2 was not a term that was under the radical, so it goes out in front, and we are done. Good. Okay. Number 4 is 6 minus x equals 2x plus 9. Good. All right, so again, we need to get all the variables to one side and the constants to the other side. And it doesn't matter which order you put them in. Or sorry, it doesn't matter if all the x's are on this side or all the x's are on the other side. Good. Since this is a negative x and this is a positive, I'm going to move the x's that way. So subtracting x, the opposite is to add x. 6 is 3x plus 9. Now I have to move that 9. Negative 3 is 3x. Divide by 3. Negative 1 is x. Good. All right, I'm going to go check my internet. 1 second. All right, hopefully that's better. All right. So x is negative 1 for that one. Number 5 would be 7 minus, so be very careful with this one. 7 minus the quantity, 2x minus 1 is 10. You're not distributing the 7, you're actually distributing only that negative sign. So the negative gets distributed to the 2x and the negative gets distributed to the negative 1. That's rewritten as 7 minus 2x plus 1, okay? Because we're not multiplying the 7, so we're just combining these. Equals 10. The negative times the positive became a negative. The negative times the negative became a positive. 7 minus 2x plus 1. 7 plus 1 is 8 minus 2x equals 10. Subtract 8. Subtract 8. Negative 2x equals 2. Divide by negative 2. X is, again, negative 1 for number 5. So 4 and 5, the answer was negative 1 both times. Number 6 is 3 times 2 minus x equals 2x minus 1. Good. All right. Distribute the 3 this time. 3 times 2 is 6. 3 times negative 1 is negative 3. Or sorry, negative x is negative 3x. Everything over here stays the same. I'm going to move the x's to one side and the whole numbers to the other. So this time I'll do it to where the x is negative, but it's up to you. It does not matter. Now I have 6 minus 5x equals negative 1. Good. All right, move the 6. Definitely would have made more sense to move it the other way, but that's all right. Negative 5x equals negative 7. Good. Divide by negative 5. Divide by negative 5. X is 7/5. My last one, I might just do it on a new piece of paper. So the last one was x times 1 plus 2x is 2x minus 1 times x minus 2 Good. Distributing that x, we get x plus 2x squared, right? Equals. Here, these are being multiplied, so you need to FOIL. 2x times x is 2x squared. 2x times negative 2 is negative 4x. Negative 1 times x is negative x. Negative 1 times negative 2 is a positive 2. Does everybody else get that when they work it? You can combine these two. X plus 2x squared is 2x squared. Negative 4x minus x is minus 5x plus 2. Good. All right, so now I'm going to move all, if you have x squared and x, you want them all moved to one side. All right, so I'm going to subtract 2x squared and I'm going to add 5x to both sides. Do you see how I lined them up? So the positive 5x is being combined with the x, the negative 2x squared is being combined with the 2x squared. So this is 6x. Positive 2x squared minus 2x squared is canceled out, and we get 2. Good. So now I have 6x equals 2. Divide by 6 to cancel out the multiplying by 6. X equals 2/6. I can divide both 2 and 6 by 2 and I get 1/3. Good. Is the video any better in the classroom? I apologize, guys. Oh, good. It was stressing. Okay. Equations with fractions, the things that make it difficult. But don't worry. What you want to do is first clear all grouping symbols. Then identify the least common denominator. Denominator is the bottom number, right? So if you have your denominators of 2 and 4, for example, the least common denominator is the smallest number I can divide 4 into and divide 2 into, okay? Here it'll be 2, 2, and 8. Here it'll be 4 and 3. Here it'll be 2 and 3, but remember I'm going to distribute those, so it might not actually be 4 and 3. It might change. Good. Multiply both sides of the equation by the least common denominator after you find it, then solve and check. So this looks difficult. I think you'll get used to it. So here we have 1/2 x minus 5 is equal to 3/4 x. My least common denominator, a number they will divide into evenly. So I can take the number 4, right? 4 divided by 4 is 1, and 4 divided by 2 is 2. So the smallest number that I can, that are, like if I multiply this by a number, I'll get 4, and if I multiply this by a number, I'll get 4, my least common denominator. Okay, so you're looking for a multiple of 2 and a multiple of 4, but the smallest one possible. In this case, it's 4. So we're going to take both sides of the equation and multiply it by the least common denominator. Because we have fractions, the way you multiply with fractions is to turn that least common denominator into a fraction. I think that's the easiest way. Any questions? So a multiple of 2 is 4 and a multiple of 4 is 4. You could also use 8, right? You could use 12, but we want the smallest one. Now, 4 over 1 times 1 over 2 becomes 4 over 2x. Is that okay? -5 times that same 4. -5 times 4 is 20, right? 3 times 4 divided by 4. Sorry, it's not. Yeah, 4 sorry, I thought that was thought that was my answer for that one. Okay, so 4/2x minus 20 equals 3/4 times 4/1 becomes 3 times 4/4, or, right, 3. 3 times 4 is 12, 4 times 1 is 4. 12/4 is the same as 3/1, which is 3x. Is that okay? Did not explain that well. All right, 3 times 4 is 12. 4 times 1 is 4. Changing my answer. Because that's what we were doing over here. 4/2x. So we said 4 times 1 is 4, 1 times 2 is 2. 4 times 3 is 12, 4 times 1 is 4. Is that right? Okay, so now we have 4/2x minus 20 equals 12/4x. 4 divided by 2 is 2, right? 12 divided by 4 is 3. Good. Now I'm just going to solve it because I got rid of my fractions. -20 is x. Is that right? Okay. Next one was x plus 5/2 plus 1/2 equals 2x minus x minus 3/8. So we're looking for a multiple of 2 and a multiple of 8. Again, our multiple of 2 and 4 here was 4, so our multiple of 2 and 8 here can be 8. I'm going to take all of those and multiply them by 8. So we have 8/1 times x plus 5/2 plus 8/1. So 8/1 times all of this times 1/2 equals 2x times 8/1 minus 8/1 times x minus 3/8. Okay. 8 divided by 2 becomes 4, right? So we can call that 4 times x plus 5. Is that okay? 8 divided by 2 is again 4, so that just becomes 4. 2x times 8, that becomes 16x. X minus 3, 8, but it's being divided by 8, so that cancels out. So we just say minus x minus 3, preserving the parentheses. That's very important. Okay, so here we took the 8 and the 2. 8 divided by 2 is 4. Okay, this 8 divided by 2 becomes this 4. The 2 being multiplied by the 8 becomes the 16. And these two 8s completely cancel out to 1. That's like an invisible 1 in front of this. We completely canceled out the 8. Any questions? So I skipped a step. Here I said 4 times 2, 4 times 1, 1 times 2 is 4/2, but it becomes 2, right? Because 4 divided by 2 is 2. Here I skipped that step. I just said 8 divided by 2 is 4. 8 divided by 2 is 4. There is no fraction here, so it's just multiplication. 2 times 8 is 16. 8 divided by 8 is just a 1, so that completely cancels out. Now I'm going to distribute 4 times x is 4x. 4 times 5 is 20. Plus 4. 16x minus, I'm going to distribute that minus sign, minus x plus 3. Because this is a grouping symbol, so we were subtracting all of the x minus 3. So subtract x, add 3. Combine like terms, 4x plus 24 is 15x plus 3. Now I'm just going to move, subtract 4x, and at the same time, you can subtract the 3. 24 minus 3 is 21. 15 minus 4 is 11. Good. Last step, just divide by 11. I would leave it as a fraction. So it's 21 over 11 is x. Fourth one, I'll rewrite it up here. I'm already out of room. So we have 1/4 times x minus 1 plus 1 equals 1/3 times x plus 6. So I know in the directions it said get rid of the grouping symbols first, but I think since the things we need to distribute are fractions and we want to get rid of the fractions, I'm just going to leave them like that. No? No. No, we'll distribute them. Sorry. So it's 1/4 x minus 1/4 plus 1. So that 1 stays alone equals 1/3 x plus 6 divided by 3 is 2, right? So if I'm multiplying 1/3 times 6 over 1, 6 times 1 is 6 on the top, 3 on the bottom, 6 divided by 3 is 2. That's how I got that. All right, now I'm going to look at my denominators. 4, a 4, and a 3. The multiples of 4 and 3, the smallest one that is common to 4 and 3 is what? And I'm going to multiply both sides by it. It's the number 12, right? So I'm going to multiply both sides of the equation by 12 in order to simplify and get rid of all the fractions. So that becomes 12 over 4x minus 12 over 4 plus 12 times 1 is 12, right? Equals 12 over 3x plus 2 times 12 is 24. Any questions? So this is more like the first example where I didn't simplify it immediately. I didn't say 12 divided by 4 is 3, right? I put it as 12 divided by 4. But 12 divided by 4 is 3. So 3x minus 3 plus 12 equals 12 divided by 3 now is 4x plus 24. Any questions? And that's just a different way of writing it than saying writing each one next to it individually. I just put parentheses around the whole thing and distributed the 12. Good. All right, so we can combine like terms. -3 and +12 become 9, right? So now it's 3x plus 9 because the 12 was positive equals 4x plus 24. Subtract 9, subtract 9. 15. So 3x equals 4x plus 15. Now subtract the 4x. Again, it doesn't matter if you go this way with the x's and the other way with the constants, or you move 3x over to 4x so that you don't have a negative. That's also fine. Negative x equals 15. I don't want the x to be negative, so I can divide by a -1. Anything I do to this side, I have to do to this side. And so positive x equals a -15. Our fourth example was 1/2 times x plus 5 minus 4 equals 1/3 times 2x minus 1. So if I'm going to distribute first, I get 1/2 x plus 5/2, right? Multiplying 1 by 1/2 is the same as dividing by 2. 5 times 1 is 5 on the top. 2 times 1 is 2 on the bottom. Minus 4, because I'm not distributing the 1/2 to the 4. 1/3 times 2x is 2/3 x. The 2 is on the top, the 3 was on the bottom. 1/3 times a -1 is just a -1/3, right? All right. Our denominators are 2, 2, and 3, and 3. So our greatest common factor that we're multiplying everything by is the smallest number that I can take and divide it by 3 and 2. What number can I divide by both 3 and 2? 6. Right? Also 12, but we want the smallest one. Again, here we said 12 divided by 4 is 12 over 4. Or you can say 6 divided by 2. I already know that is 3. Okay? Here, 6 divided by 2 is 3 times that original 5. 6 times 4 is 24, and it's a negative. 6 divided by 3 becomes 2 times that original 2. 6 divided by 3 is again 2. So 6 divided by 2 became that 3. 6 divided by 2 became that 3. 6 divided by 3 became that 2. And I'm out. And then 6 divided by that 3 became that 2. This 2's right here. This 5's right here, in case you are confused as to where all of those numbers came from. Okay, you can also write it as 6 times 1 over 3 times 2, which is 6 times 1. Oh, sorry. 6 times 1 over 1 times 2, not that 3, right? 6 times 1 is 6 times 1, 1 times 2 is 2. 6 divided by 2 becomes 3, right? Here it would be 1/6 times 5 over 1 times 2. 6 times 5 becomes 30 over 2, which becomes 15, which is 3 times 5. Here it was just 6 times 4 is 24. 2/3, 6 over 1 is 2 times 6 over 3 times 1. 2 times 6 is 12. 3 times 1 is 4. 12 over 4. Sorry, 12 over 3 is 4. 2 times 2 is 4. 1 times 6 over 3 times 1 becomes 6 over 3, which is 2. So we have 3x plus 15 minus 24 is 4x minus 2. So that's 3x minus 9, right? Negative 24 plus 15 is a negative 9 equals 4x minus 2. Sorry, I went off the screen. Now, I want my x to be positive this time, so I'm going to subtract the 3x so that I don't get a negative x. That means my x's are going this way, so my constants have to go the other way, so I'm going to add 2. Is that all right? Negative 9 plus 2, so 9 minus 2 is 7, but it's a negative 7 because that 9 was negative, is 4 minus 3 is a positive x. So that's what you do with fractions. We have one more fractions example. It's a bad one. I think it's on the other side of this one. All right. 1 over the quantity 2x plus 3 times x minus 1 equals 1 over x minus 1 plus negative 4 over 2x plus 3. Good. We still need a least common denominator. So in the past, it was 6, it was 4, and it was 8. Here, our denominators are this, and this. So what can I multiply all of these? What are some multiples of all of these? What's one multiple that will cover all of this? What if I multiply it all by this one? 2x plus 3 times x minus 1. Well, it includes that one, and it includes that one. So I think I can multiply everything by 2x plus 3 times x minus 1. And remember, I'm distributing that here and here, okay? So if I cross multiply, let's write it out. So here on top, I have 2x plus 3 times x minus 1 over 2x plus 3 times x minus 1, because I was multiplying that by that number 1, right? Equals, here I'm distributing this here. 2x plus 3 times x plus 1 over only x minus 1. Oops, sorry, there should be a minus. Thank goodness. It'd be a mess if it wasn't. Plus negative 4 times 2x plus 3 times x minus 1 over only 2x plus 3. Okay, so now that it's all written out, what can we cancel? Those cancel, and those cancel, right? You can't call it 0, we just call it 1, okay? Because we're left with a 1 on the top and a 1 on the bottom. 1 over 1 is 1, right? This side, you can cancel this, and you're left with 2x plus 3 plus, what can cancel here? The 2x plus 3, negative 4 times x minus 1. Okay, I'm putting all of that in parentheses because it was a fraction is a grouping symbol. Good, so we're adding all of that. So if it was subtraction, it would really matter, but since it's addition, it doesn't. 1 over 1 becomes 1 equals 2x plus 3, and we should be no more fractions, right? We got rid of all our fractions, minus, and I'm going to distribute the 4x plus 4, okay? So I had to distribute the negative 4 to the x and the negative 4 to the negative 1. So I got 4x plus 4. Now I can combine like terms, add 3 and 4 together, and then the 2x and the negative 4x together. So I get 1 equals 2 minus 4x is negative 2x. Adding 3 and 4, I get 7. I have a 1 over here, a negative 2x, and a 7 over here. I could move the 7 so that I don't have to move the 1 and the 2, but then they'll both be negative. So I'm going to move the 2 so that I get it positive, right? I like positive variables. So that becomes 2x plus 1 equals 7. Subtract the 1. 2x equals 6. Divide by 2. X is 3. All right, I know we did not get very far, but definitely the most difficult part is the fractions. So we can do, the rest of this will go very quickly. All we're doing is, sometimes you will get no solution because this is a 3x and this will become a 3x. They cancel each other out. Here you have x plus 3 and x plus 3. What ends up canceling it? Anyway, they will cancel each other out. And if what you have at the end is false, you say no solution. If what you have at the end is true, you say infinite solutions, right? If 2 always equals 2, then it doesn't matter what x is. If 2 always equals 0, it doesn't matter what x is, it will never be true, okay? So that's what, don't worry about it. If you encounter those problems on My Math Lab, wait, and we will start this on Friday, okay? I'm gonna pause the video. All right, class ended, but I did want to finish this video and I will just add it to the end of our class video. So what happens if we are working on equations in one variable with variable x and the x cancels itself out as we are solving it? If the remaining statement, so everything that is left after the x's disappear, if the remaining statement is false, we say no solution. If that remaining statement is true, then there are infinite solutions. So infinite solutions would be if it was 0 equals 0 or 5 equals 5, for example. Then that would be all real numbers or infinite solutions. No solution would be something that looks like 1 equals 2, anything that doesn't fit together, 0 equals 10, okay? These will never be true no matter what value you put in for x. These are always true, so it doesn't really matter what value you put in for x. That's the difference between infinite solution and no solution. So let's just solve these and see what we get. So we have 3x plus 5 equals 3 times the quantity x plus 2. 3 times x becomes 3x. 3 times a positive 2 becomes 6. So we have 3x plus 6 on this side and 3x plus 5 on this side. You can already see, right? You can already see that some parts, we have a 3x plus, but this is a 5 and this is a 6. So you can already see that might be a problem. If these were exactly the same, you could say infinite solutions. These are not exactly the same. We'll keep working at it. So I'll move all my x's over by subtracting 3x. If I subtract 3x from both sides, it cancels here. I'm left with 6. And 3x minus 3x cancels here as well. And so I'm left with a positive 5. 5 equals 6. That is no solution because it is not true. Okay, we'll do again, same problem, different so instead of moving the 3's, I'll move the x's. Or sorry, instead of moving the 3's, I'll move a 5 perhaps. And I'll get a different answer, but it will still be no solution answer. So 3 times x is still 3x. 3 times 2 is still a positive 6. Over here, we still have 3x plus 5. Good. Now I want to move the constant. So the constant is a positive 5. I'll subtract 5. Now I have 3x equals 3x plus 1. We can kind of see that that's not going to be true, right? I'll move that 3x. They cancel. I get a 0 equals 1, okay? Either way, it's still no solution. In both of those situations, you do not have anything that is true. 5 is not equal to 6 and 0 is not equal to 1. So those are no solution no matter how you choose to solve it, okay? This one is 2x over x plus 3 equals negative 6 over x plus 3 minus 2. So we've done some fractions. What we do to get rid of the fraction is we multiply everything by a common denominator. In this case, it would be x plus 3, x plus 3. So if I take x plus 3 times 2x divided by x plus 3, those cancel, right? And I'm left with 2x equals negative 6 over x plus 3. The x plus 3 cancels, so it's just negative 6. But minus 2, I do have to distribute that x plus 3 to the minus 2, so it'll be minus 2 times x plus 3. That becomes 2x equals negative 6 minus 2 gets distributed to the x, so it's minus 2x, and the negative 2 gets distributed to the 3, minus 6. Good. So now I have common, one second. Okay, I'm going to change this. I'm going to change this to a plus 2. All right. So that is now a positive 2 times the 2x times the 3. So I'm going to change those to plus 2x and plus 6. Good. All right. Negative 6 plus 6 canceled. I'm left with 2x equals 2x. Good. That is the same, right? So we can say those are infinite solutions. This is true. So it's infinite solutions. And I know that's only because I changed the equation, but that's because I had made a mistake and I always forget. All right, so that's infinite solutions. Or if I had, I'll do it a different way. Ooh, we can keep going. 2x equals 2x. Divide by 2 on both sides. I get x equals x. Good. Even if I kept going, subtract x, I get 0 equals 0. This is still true. This is still true. And this is true. So this is always infinite solutions. Good. All right. So that if there are no letters by the time you are done solving it, you decide whether it's no solution or, remember, these is infinite solutions, and it might be all real numbers. All right, 2 more examples. So applied problems just means word problems. So we're going to read the problem carefully, pay attention to the question so that you know that you are looking for, you know what you are looking for. Identify any relevant formulas you may need. Create a variable to represent the information that is missing. And then express remaining unknown quantities in terms of this variable. Okay. Make a list of all your facts, translate those facts into math expressions, solve for the variable, and find out or decide whether that answers your question. If they're talking about days, does that look like an appropriate number of days for the situation? If they're talking about miles, is that not a negative number, you know? And then you can even put that number back into the problem to make sure that it also works with the numbers that you had chosen for your problem. For example, a total of $10,000 is to be invested in stocks and bonds, okay? If the amount invested in bonds is 1/4 that invested in stocks, how much is invested in each category? So what were our directions? We need to decide what our variables are. We have $10,000, right? We have stocks and we have bonds, and then we have some information about the stocks and bonds. So I'm going to create the variables S and B because they are different values, right? The amount invested in bonds is, right, is equals 1/4 the amount invested in stocks. So bonds is 1/4 of stocks, and I can find another equation. My other equation is that 10,000 total equals stocks and bonds, right? 10,000 is invested some amount in stocks and some amount in bonds. If I put that money, if I put the money of stocks and the money of bonds together, I will get $10,000 total. Okay. Another important point is express the unknown quantities in terms of that variable. Okay. So if I have 100 equals 5x plus 10y, instead of having two variables, x and y, if I can take that y and put it as a form of x, that helps me to have only one variable for my equation. Okay, because these are equations in one variable today. So I can't have x and y. I want them all to be one letter. Good. Here I have 10,000 equals S and B. But I also know that bonds are 1/4 of stocks. So instead of B, I can put in 1/4 S. Okay. So instead of 10,000 equals S plus B, I can say 10,000 equals S plus 1/4 S. Does that make sense? Okay. So this is 1S, this is 1/4 S. Good. How much is 1/4 as a decimal? If I was to combine 1 and 1/4, it's kind of easier to write it as a decimal. So that's 1S plus 0.25S, right? Because a fourth of a whole is 25%. Good. So if I combine 1S and 0.25S, I get 10,000 equals 1.25S. The stocks and bonds together make 1 and another quarter stocks. Good. Okay. Now I need to solve for S. It's being multiplied by 1.25. I'm going to divide it by 1.25. 10,000 divided by 1.25 is 8,000. So the S value is 8,000. Okay, let's look back at our information. We had $10,000. We put some in stocks, some in bonds. We took out the bonds from that equation and we put in stocks again because stocks is 1/4 of the bonds. Bonds is 1/4 of the stock. Okay, so we took out the B and put in 0.25S. So we have a whole S for the to stand for the stocks, and then we have 25% of the S to stand for the bonds. We combined those, we got 1.25. We divided our total 10,000 by 1.25, we got 8,000. Good. 8,000 is S. So now, if I say B equals 1/4 of, instead of S up here, I'm going to say 8,000. Good. Or 0.25 of 8,000, right? If I multiply 8,000 by 0.25, I get 2,000. Does that work for my original equation? 10,000 equals B plus S, or 2,000 plus 8,000. That one is true. And then 2,000, this equation up here, bonds is 1/4 stocks. 2,000 is 1/4 of stocks we decided was 8,000. Or 2,000 is 0.25 of 8,000. That is also true. Good. A total of 10,000 is to be invested, some in stocks, some in bonds. If the amount invested in bonds is 1/4 that invested in stocks, how much is invested in each category? So we said 2,000 in bonds, 8,000 in stock. Good. So it works with the $10,000 equation. It works with the 1/4 of the stocks equation, and it makes sense. I put $2,000 in bonds and I put $8,000 in stocks. That is plausible if I have $10,000. All right, last example. Lee is paid time and a half for hours worked in excess of 40 hours and double time for hours worked on Sunday. If Lee has wages of 10,083 for working 50 hours, 4 of which were on Sunday, what is her regular hourly rate? I was saying wage. All right. What are our variables? We have hours, right? But we have Sunday hours are 2 times our regular hours, right? And we have time and a half hours. So we work our regular job, we just get our hourly wage. We get overtime, or time and a half, right? And we get our weekend pay, our Sunday pay. I'm going to call time and a half O for overtime. Good. So we know that she has 50 hours, right? 4 were on a Sunday, and she only gets 40 for her regular hours. So her regular hours were 40. Her Sunday hours were 4. And if we're just going to say 40 plus 4 is 44, but she worked 50 hours in all. So we're going to say that she worked 6 overtime hours and that the overtime hours did not overlap with the Sunday hours. Okay, so we have 40 regular hours, 6 overtime hours, and 4 Sunday hours. She earned, right? She earned $1,083 that week. She got 40 hours for her wage, right? Or we can say rate. I can't decide between rate and wage. I'm going to say rate. So her rate times 40, right? And then for those extra 4 hours on Sunday, what happens? She pays double time for hours worked on Sunday. So the 4 Sunday hours are going to be 2 times her rate. And she also worked 6 overtime hours, which are 1.5 times her rate. Okay, so first I decided, okay, 40 hours at regular pay, 6 hours at time and a half pay, and 4 hours at 2 times her pay. I did it all in one variable of rate, even though we had many different variables to think about, right? Okay, now we can just combine this. 1083 is 40R plus 4 times 2 is 8R, right? Plus 6 times 1.5 is 9. 1.5 times 6 is 9. Good. I can combine those. 40 plus 8 plus 9. 57. So she worked 50 hours, but she's going to get paid for 57 of those hours. Good, because some of them were overtime and some of them were Sunday pay. Now I just need to take 1,083 and divide it by 57. Oops. Her hourly wage is $19 an hour. Does that make sense? She's paid overtime for hours worked in excess of 40 hours, double time for hours worked on Sunday, gross weekly wage of 1,083 for 50 hours. Regular hourly rate is 19, so I can put that back in here. 40 times 19 plus 4 times 2 times 19 plus 6 times 1.5 times 19, and we get, oops, I'm sorry, $1,083. So that does make sense with the equation that we worked.